This presentation was originally delivered at the National Stormwater Practitioners Virtual Forum, October 18th and 19th, 2021. Good morning. I'm here today to describe information developed by the USGS in cooperation with the Federal Highway Administration Office of Project Delivery and Environmental Review and several state DOTs that may be useful for addressing TMDLs and other stormwater issues. The two primary tools provided by the Federal Highway Administration and the USGS are the Stochastic Empirical Loading and Dilution Model, SELDM, and the Highway Runoff Database, HRDB. SELDM is a simple-to-use runoff quality model that can be used to simulate runoff from highways and other land uses to obtain flows, concentrations, and loads of stormwater. The Highway Runoff Database holds state DOT highway runoff data and provides data and statistics that can be used with SELDM or independently for other analyses. SELDM and the Highway Runoff Database were thoroughly reviewed and tested. For example, engineers, hydrologists, and environmental specialists from the USGS, the Federal Highway Administration, the US EPA, the Fish and Wildlife Service, 15 state DOTs, and the Massachusetts Department of Environmental Protection participated in the SELDM beta test process and/or the official model review. SELDM was adopted by the National Cooperative Highway Runoff Program, NCHRP, study on TMDLs as a primary analysis tool. The results of the study were published in the NCHRP Technical Report 918. The NCHRP study used the Pacific Northwest as an example and found that highway yields, which are loads per unit area, were high, but watershed loads from highways were minor. This will be a common theme across several studies. The NCHRP project focused on SELDM because it provides robust results without requiring advanced modeling skills. People who come to the SELDM class are running the model after a 40-minute introduction to it. This graph from the EPA guidance on environmental models shows the battle between having a complex model and the need for more and more data to get a reasonable result. A complex model can provide information that's much worse than a simpler model without a large investment in the effort to construct a complex model, obtain representative data, and fit model results. In contrast, because SELDM and the Highway Runoff Database are preloaded with much of the data that you need, we minimize complexity and data uncertainty. Once you know SELDM, you can generate initial planning level estimates within an hour, and you can develop refined estimates within an afternoon. Many state DOTs have decided that SELDM is a useful tool. Our contacts with DOTs and others indicate that SELDM is or has been used in at least 14 states. If people in your state are using SELDM or the Highway Runoff Database, please have them reach out to us for technical support, training, or updates on new information as it comes out. SELDM provides storm and annual flows, concentrations, and loads with and without BMP treatment. This graph shows a simulated population of 29 yearly values. The vertical axis is a linear scale showing the annual highway yields for total phosphorus in pounds per acre per year. The horizontal axis is a probability scale showing the percentage of years that equal or exceed a given value. For a TMDL analysis, we would use the long-term average because it is the entire 29-year load divided by the number of years. The stochastic analysis shows the information we may want to use to assess variability and estimate a margin of safety. The stochastic analysis also shows that the total BMP reductions are not a simple product of average concentration and flow reductions. The Highway Runoff Database, HRDB, supports runoff quality analyses because it has runoff and water quality data and statistics from the Federal Highway 1990s dataset and 18 state datasets. As you can see, there are many datasets, highway sites, runoff events, and event mean concentrations in the database. There are 414 different water quality properties or constituents, including turbidity, pH, sediment and solids, nutrients, metals, bacteria, and many organic chemicals. Although we have a robust data set, we are always looking to expand the data to cover different site conditions and to keep up with changes in runoff quality through time. We also provide runoff treatment statistics. In our 2021 BMP study, we generated statistics for flow reduction, hydrograph extension, and 51 water quality constituents in 11 major groups, including turbidity, pH, sediment and solids, nutrients, metals, bacteria, and organic chemicals. This diagram shows the different groups of water quality properties and constituents with the number of samples represented by the font sizes. Now, I'll discuss a few examples starting with a study we did with the Oregon DOT. In this study, we added the DOT road information and different land covers to StreamStats, and then used that information to estimate phosphorus loads in the Willamette Basin south of Portland, Oregon. This is a pie chart showing the percentage of long-term average stormwater runoff loads attributable to each land cover in the Willamette Basin. Highway yields, which are loads per unit area, are highest because the highway is impervious, but as seen in this pie chart, the highway loads are a small percentage of the basin-wide loads. This is because the highway area is a very small fraction of the total basin area. Our BMP simulations demonstrated that Oregon DOT could not solve the problem in the Willamette Basin alone because highways are just a small part of the total load. Minor reductions by others, however, could achieve the same results. This is a bar chart showing the percentage reduction needed for each source area to meet target reduction goals for total phosphorus loads in runoff by itself. The bars represent the percentage reductions needed if the entire reduction was going to be achieved with only one land cover category. The graph shows that removal of all highways would not meet some goals if the DOT was solely responsible for meeting the reduction goals. In comparison, minor reductions in non-DOT loads have a much greater effect. In another example, we helped Massachusetts DOT and their consultants use SELDM and GIS to calculate loads for 89 coastal bays. Our analyses helped reduce EPA highway runoff estimates of total nitrogen from 9.1 to 4.4% of the total impervious area loads. The cost of this approach was much less than, and the timelines were much shorter than, using complex watershed models like SWIM. In this case, the simpler SELDM results were more representative of actual conditions than the complex model results. In another TMDL study, we simulated ecoregion and basin-specific highway and urban runoff yields in cooperation with CalTrans. When CalTrans uses GIS to determine their impervious area and the other impervious developed area in individual TMDL basins, they will be able to use that information with our published yields to show the highway and non-highway loads with and without commonly used BMPs. Currently, we are following a similar approach in cooperation with the Connecticut, Massachusetts, and Rhode Island DOTs. We will be simulating highway and urban runoff yields for each ecoregion and all 45 precipitation stations in and around southern New England. This information can be used by the DOTs to address current and impending TMDLs. In southern New England, we also added road links and crossings to StreamStats that can be used to assess the DOT's roadway footprint and their share of impervious area storm loads. In most basins, state-maintained roads are a small fraction of the total roadway area and an even smaller fraction of the total impervious area. This information and the runoff yields we are developing can be used to address current and future TMDLs. This table is an example of the application of StreamStats roadway and impervious cover data with simulated yields from SELDM to estimate stormwater loads. In this example, the simulated long-term average annual stormwater runoff loads from 10 river basin tributaries to the Narragansett Bay are shown. About 27 tons of total nitrogen is from highways, and, if the International BMP database values are used, 675 tons of total nitrogen are from other developed areas. Using these values, highways are about 2% of the developed area and produce about 4% of the loads from developed areas. If the National Stormwater Quality Database statistics for urban runoff are used instead of the international BMP values, then the other developed areas produce about 1,100 tons of total nitrogen, and the highways are about 2.4% of the developed area stormwater loads. If we count loads from wastewater treatment plants and other dry weather discharges, the highway contribution is a much smaller source. Besides TMDLs, we also use SELDM to look at risk for water quality exceedances and the potential effectiveness of management measures. For example, in Massachusetts, we did an urban runoff study with SELDM indicating that phosphorus criteria were unobtainable at 1% impervious cover. This indicates that stormwater may be above water quality criteria even in minimally developed basins, which limits the DOT's capability to address nutrient issues. In North Carolina, we are developing an innovative approach to regulatory compliance. We use SELDM in cooperation with the Federal Highway Administration, North Carolina DOT, and their regulators to develop a simple and quick decision tool for BMP selection from highway and upstream basin properties. These properties include the location of the site, highway and upstream drainage area, main channel length, main channel slope, and imperviousness. The process can be used by highway engineers and decision makers to evaluate potential effects of runoff at any site within minutes and without any specialized modeling skills. If you are interested in what you have heard, we will be having an online class for SELDM and the Highway Runoff Database this fall 2021 or early winter 2022 with a few webinars and details on YouTube. Send an email to seldmtrain@gmail.com if you are interested. If you have new people in your section, we will be covering the model and a lot of basic highway hydrology and water quality concepts. If you've taken the class in the past, you are welcome to sit in or visit the YouTube site for a refresher. The YouTube site also has recordings of webinars and conference presentations, including ones on BMP treatment, roads and StreamStats, and loads to the Narragansett Bay. If you regularly deal with state or federal regulators, they are welcome as well. Finally, links to SELDM, the Highway Runoff Database, software, data, and SELDM reports are available on the SELDM webpage at www.usgs.gov/SELDM. If you're interested in more information, please feel free to follow these links, and our contact information is on that page. You can also search the USGS Publications Warehouse or other sources for SELDM-related information. Thank you for your time today. Goodbye.